Hello everyone, my name is Monika Bhushan and today we are starting lecture number 11 of differential equation. Okay, so in today's class we are starting the new topic which is called as Cauchy's homogeneous linear differential equation, or we call it Cauchy-Euler differential equation. So if you will see the standard form of this differential equation, then only we will come to know that why this is something different from what we have done till now. This is lecture number 11, and till lecture number 10 we had seen many different forms, all 5 types we have solved for the differential equation. So why this is something special, why this is something different, we are going to understand now. Okay, so very first thing is, as if you'll see this complete name, so we know that this is equation, we know that this is differential equation if we will look at this special form, right, of differential equation. And why I'm calling this is differential equation, again the same thing. The reason is we can see that we have the dependent variable, y is dependent variable, and even we can see that the derivatives of dependent variables are also present, right? So what is the definition of differential equation? We can find the dependent variable and one or more of its derivative present in the equation. This is called as differential equation, right? We see that this is dy by dx, that means y is dependent variable, right, and x is independent variable. Everything we have covered in first lecture only. Okay, now come to the term which is linear, right? Linear also, if you recall what we had discussed about linear differential equation. Suppose I am taking one example here. This is x square d2y by dx square plus 9x dy by dx plus 7y, suppose, equals something 5x. So 5x is what? Some function which is with respect to x. So if this differential equation we will just analyze, so we'll say that this is linear in nature. Why so? Why this is linear in nature? So the linear differential equation will have the power of dependent variable 1. Okay, this is y is dependent variable, we know the power of y is 1. Even the derivatives of dependent variable will be 1. So dy by dx also, the power of dy by dx is 1. That means we don't have dy by dx whole square, right, or dy by dx whole cube kind of thing. Similarly, d2y by dx square, this is again one more derivative with respect to dependent variable. Here also we are not seeing something which has power 4 or power 2 or power 3. So this is linear in nature. Okay, so one question will arise that here you can see that this is x square. So why I'm saying this is linear in nature? Because this formula or this rule is only for your dependent variable or the derivative of dependent variable. We don't worry if it is x square, x cube, x to the power 3, x to the power 4, anything, we don't worry about it. We are just concentrating on the power of derivative of dependent variable or the dependent variable itself. Okay, so I think now this is clear that what is linear differential equation. Now we are coming to the Cauchy's homogeneous, this complete form. Okay, so this complete thing is the standard form of Cauchy homogeneous linear differential equation. Here something special if we can see is a naught x to the power n dny by dxn plus a1 x to the power n minus 1 d n minus 1 y by dx n minus 1, and so on till we are writing down it as plus x and y equals phi x. Phi x is nothing but some function which is with respect to x. Okay, now come to the left hand side. Here we see that this type of differential equation or this type of linear differential equation has constant coefficient. That is okay, constant coefficients are also there. So but along with constant coefficient, we see that here in each and every term, the power of x is multiplying with the derivative of y with the same power, right? That means here this is x to the power n d ny by dx n. Similarly, if it is my d n minus 1 y by dx n minus 1, so it is multiplying with x to the power n minus 1. So if this type of special form, if we will be seeing, so it will be called as Cauchy's homogeneous linear differential equation. Okay, now we have seen how to solve differential equation using type 1 of PI till my type 5, correct? Right, all those 5 types we had seen to solve the differential equation. Can we apply this one of any types in this differential equation to solve it? So there you will see that we used to solve differential equation which was also linear differential equation, right? But it was always linear differential equation with constant coefficient. Constant coefficients are also there along with this variable which is present, right? In each and every term you will find that x power n minus 1 and so on is getting multiplied. So you will see that this type of form we had not seen to solve type 1, type 5 or anything, all those types, right? So here we don't have any x term y because we don't have derivative also, right? Here the dy by dx is not there, so x is also missing here, only y is there. Okay, so this is the general standard form of Cauchy's homogeneous linear differential equation, and we will find that we cannot solve this differential equation using type 1, type 2, type 3, type 4 or type 5 because of the presence of this variable which is multiplying in each and every term. Okay, so if we want to solve this differential equation using these 5 types, because we have done it, so what we have to do? So some transformations, some substitutions we have to make, and then we will be coming to just solve the same way like how we used to solve the differential equation, right? So only 2 steps are needed which are extra to solve this type of differential equation, and then it will look like you are solving the differential equation using type 1, type 2 and so on. So I will suggest you that please see those types first to solve this type of differential equation. Now, what substitution we have to make here to solve using type 1, type 2 and so on? So here we will be using something which will be treated as formula. That will be your, if I'm writing down x d by dx with respect to y, because here the dependent variable is y, right? So x ka power 1 and then dy by dx. Dy by dx, this is just d1y dx1 you can say, right? So x dy by dx we will be substituting with capital dy. And what is this capital D? Capital D is called as differential operator, correct? So x d by dx will be treated as d. Now similarly, what we are writing down here, if it is x square d2y by dx square, that means x has power 2 and then d2y by dx square. So we will be using twice d, okay? But the d term which is multiplying with each other, it will be d and then d minus 1 and then it will be y. Y is this y with respect to y, whatever we are solving it, okay? Now, so be careful that x power 3, so d3y by dx cube. Similarly, you can write down x power 4 and then d4y by dx4, okay? So this way. So if suppose it has power 3, that means x has power 3. So how many d you are going to use? 3 terms of d will be there, but that will be d minus 0, d minus 1, d minus 2 and then y. So if it is x4 d4 y by dx4, it will be what? 4 terms of d will be present, correct? No, 4 times you will be writing down d, but it will be d minus 0 you can just to memorize, and then it is your d minus 1, then d minus 2 and then d minus 3. So if it is 4 till d minus 3 it will be there and then y. So you can similarly you can write down till any power, okay? So this way we will be substituting these terms with respect to differential operator term, okay? So we'll start solving the question, then it will be much more easier to understand what we are talking about. Okay, so now we are solving these questions. So very first question, if you just focus, so what this question says us, this says that this is x square y double dash plus x y dash plus 9y equals 3x square plus sine 3 log x. So in the question they will not write to solve it using Cauchy homogeneous differential equation kind of thing. They will not give you this hint. you have to understand that which method you have to follow. They will just be giving you in your paper, solve the differential equation. Totally up to you how you are going to start. So always I will suggest you start with what we started with our differential equation playlist right now, the type 1. Always start with type 1, type 2, type 3, type 4, type 5. But to apply those types, these types I'm talking about with respect to CF plus PI, correct? No, so this type 1, type 2, so I'll always suggest you to please see those lectures first and then come to this lecture. Okay, so what we are talking about, type 1, type 2, there's all are type for PI. And why we are using this type? Because I have to solve this differential equation right now. If I want to use these types, so for that the linear differential equation should be in the same form also. That means the differential equation should be having constant coefficient multiplied with them. That is only the condition, and it should be linear also. I'm not worrying about the right hand side function, right? So right hand function, whatever is there, that will later come into picture when we will start finding out PI. Now we are just concentrating on the left hand side. Because of the presence of x term, we will not use these types, correct? But something else also we see here. Some special form is present here, right? What is the special form? There are three terms in your left hand side. In each term you see that if the derivative is your y double dash, right, y double dash is nothing but d2y by dx square, correct? No, so y double dash, if it is there, so it is multiplying with x square. If it is y dash is what? Dy by dx. So dy by dx is multiplying with x, right? And here I don't find any dy by dx, so no x is present here. So this form is a straightforward Cauchy's homogeneous linear differential equation form. We will solve this question under Cauchy's differential equation. And later on we'll see that like how these equations are also under Cauchy's homogeneous linear equation also. But before that we will thoroughly understand the first question, then we'll come to these questions. Okay, now, so since we have discussed about this line, now what are the two steps which I have said that only two additional steps are there, and the main goal is to start solving your different types of solving PI, type 1, type 2, type 3, type 4, type 5. Okay, so very first step, step number 1 is what? Always in this type of question you have to substitute t equals log x. Okay, x, why? Because here your independent variable is x. So we are writing as t equals log x. It will be there in all your this type of Cauchy's equations question. Okay, or you can write down what? If I'm writing down log x equals t, that means what? Log x base e equals t. Or you can write down what? You know how to convert it, right? E to the power t equals x. This is same as this. You know this one, right? This is log x base e equals t is nothing but e to the power t equals x. Okay, so this is my step number 1, what we have written down here. Now step number 2 is what? Step number 2 is what we had seen in the formula list. If it is your x dy by dx, then I'm going to write, if x power 1 is there, so only 1d and then y, because of this y. If I have x square d2y by dx square, I will be having two times this d will be present, but the second time it will be d minus 1, correct? No? Okay, so this way we will be doing. But how long I will go? This is my step 2. For that, I will check here what is the order here right now. This is your d2y by dx square. So I'll just stop here only. What we are writing down, x square y double dash will be nothing but d minus 1 y plus x y dash. Okay, so x y dash is what? X y dash is nothing but dy, fine, plus 9y, plus 9y. This is what I'm writing down, this left hand side. The very first line is this much. Okay, now what will be in my right hand side? I can see that 3x square is there, and I have to substitute x with e raised to t. So x square will be how much? E raised to 2t, correct? No, because now I'm using the variable t. We are not using with respect to x, right? Because we are doing x as e raised to t, plus this is sine 3 log x. So log x is what? E raised to t, correct? And this is base e only. So only this term if I'm writing down plus sign. So this is nothing but plus sine 3 log e, then this base is also e. So this is nothing but t only, correct? So this is my t only. So this is nothing but sine 3t. Okay, so what next step is, I'm going to rewrite if the same thing you will write here. This is nothing but your d minus 1y plus dy plus 9y is your 3 e raised to 2t plus sine 3t. Since my two steps are done, right? Only two extra steps we had to follow. Now just you imagine that this is the question given to you and you have to solve using your CF plus PI method, what we had seen different types. Okay, again if you will see your left hand side is yes linear differential equation and constant coefficient, right? You don't have any variable present here, right? And the right hand side has only one variable, that is that we can say that this is nothing but phi t, correct? Okay, so my first step is what? I have to find out CF, correct? And the second step will be I'll have to find out the PI. So we have written down here, right, whatever we have got. Now we can rewrite it as d square minus d plus 9 y equals whatever is present in my right hand side, that is phi x. Okay, or I can write down it as d square plus 9 y equals phi x. Fine. Now if you will see this form, that means we can actually use the type 1 2 3 4 5 whatever. That means I can follow the step to find CF plus PI. So I have to find CF. So what we actually do in finding CF? We rewrite the given differential equation in the form of function m equals 0, right? This is only the form which we are going to put now. So that means instead of writing d, we are writing m. Okay, so instead of writing d, we are writing m. And why we are using m only? You can use any name, any variable, m, n, p, anything you can use, right? So this is m square plus 9, but we don't add the dependent variable here. This is just m square plus 9 and the right hand side will be 0. That means the function will not be written here. We will be writing down it as 0 to make it homogeneous differential equation. Fine, this is the step and this is called as what? Auxiliary equation. So we got the auxiliary equation, or it is called as characteristic equation. Fine. Now the next step to find the complementary function is what? You have to find out the YC. And how to find YC? Based on the nature of the root of this auxiliary equation, we will be writing down what is my YC. So here we say that m is what? M is plus minus 3i, correct? Why m is plus minus 3i? Because this is my quadratic equation and we know that the roots of quadratic equation will always be 2, correct? So how many m you will be getting? How many power of m is present? Here the power of m is 2, so 2 roots you will be getting here. So and you got the roots are actually imaginary pair. So if the roots are imaginary pair, we had seen in lecture number 3 that we don't have to use here e raised to x, right? Because there is no real power. So we will be writing down c1 cos 3t plus c2 sin 3t. And why we are writing down it? Because the 3 is there with I, so 3 is present here in sin and cos, right? So this is what we had seen in finding out the complementary function in details, right? So now since we are done with YC, so my job is to find the YP, okay? And once we will find YP, so the complete solution will be YC plus YP, okay? And then we will be done. So we are now going to find the YP, okay? So fine. So how to find YP? We know that YP is nothing but whatever is phi t here, right? Because the variable now which we are using is t. Later on at the end we have to rewrite in terms of x, because the question they had asked in terms of x only, not in t, right? So phi x divided by what? Whatever is present in my left hand side, the derivative term. So the derivative term was present in my left hand side was d square plus 9, correct? And what is my phi t? So phi t was 3 e raised to 2t plus sine 3t, correct, divided by d square plus 9. So since I can see that this has the two terms present, because of this addition we have two terms in this yp, so we will be simplifying it. This is nothing but 3 e raised to 2t by d square plus 9, and then plus sine 3t by d square plus 9. Okay, now if you remember that what was the method we follow to find the pi, so always we have to start with checking with type 1. This is what we have to make the habit, like to find the what is my yp, always I will start with checking the form, whether the form is of type 1. If it is not, then I'll check with type 2, then type 3, type 4, type 5, and so on, correct? So what is the way? This is type 1. So yes, this is type 1 only. Why this is my type 1? Because I can find the exponential term present here. So because of this exponential term, I don't have to go for type 2, type 3 checking. I just come to know this is my type 1. And what was the rule which we have seen to find the pi of type 1? So this was your, we are going to write the numerator as it is, and in the denominator we are replacing d with d with 2, correct? No, why? D with a is what? E raised to 80. Type 1 is what? E raised to 80. If it is present, then it is my type 1. So we are substituting d with a, and what is a? A is 2. So it is 2 square plus 9. Okay, and what about my this type? Okay, so this term contains type 1. No, this is not type 1. Why not type 1? Because I don't find any exponential term here. Okay, whether this is my type 2? Yes, this is my type 2. Why? Because I can see the trigonometrical function present, correct? So if it is my type 2, so what I have to do? Numerator I will write as it is. In denominator I am going to substitute d square with what? Minus of a square, negative of a square. And what is my a? A is sine 80. The form is what here? Sine 80. So this a is my 3. So I am going to write d square is minus 3 square. That means minus of 9. Correct? This is not minus 3 whole square. Correct? No. This is negative of 3 square. Fine. So these all things we have seen in detail in those types. Correct? So now what we have going to do? So we are writing down this as minus 9 plus 9. Okay. So come to this first term. This first term is done. This is 3 e raised to 2t by, this is 4 plus 3 is nothing but your 13. So can I say that this term is actually, I am done with finding pi in this term, this particular term? So yes. Why? Because I cannot find any d in the numerator or any d in the denominator. That means I don't have to work anymore in this term, right? So if you have any doubt what I am talking about, I'll really suggest you to see first those types to come to this lecture. Okay, so that means I'm done with this term. Now what about my this term? I can find that the denominator is 0, right? If the denominator is 0, then what my term is? The next step what I have to follow is go back to one step previous, correct? In my one step previous, what was my denominator? Numerator will be as it is. Denominator is d square plus 9. So I have to find the derivative of that, correct? So what I am going to write down here? I am going to write down, instead of d square plus 9, I am going to write down it as 2d, correct? And then derivative of 9 is the constant, that will give you 0. That means instead of d square plus 9, I am going to write as 2d. Okay, so can I say that I am done here? Had seen that if we are going to find the derivative, then we have to multiply in the numerator this t or x, whatever is independent variable. This complete rules we have seen in type 2. Okay, so this is nothing but your t sine 3t by 2d, and now I am going to rewrite it as t by 2. Okay, and then this is nothing but 1 by d sine 3t, correct? Okay, can I say that my job is done here? No. Why? Because I can find the d, the differential operator is present, and here this is in the denominator. So this is nothing but inverse differential operator, and we had seen that 1 by d is nothing but integration with respect to, if it is t is present, so with respect to t. because we know that d is nothing but d by dt, and 1 by d is nothing but integration with respect to t. So here t by 2 just I'm keeping aside, okay, and this is nothing but integration of sine 3t dt. Okay, so it will give you how much? T by 2 just aside. So sine 3t integration will give you minus cos 3t divided by 3. That means minus t cos 3t by 6. Can I say that my job is done? Yes, because I can't find d in the numerator or denominator. That means you got your yp. This was your yp first part. This is your yp second part. So fine. So we also have got the same thing, right? So my complete solution of the given question is what? Yc plus yp. Okay. So yc, whatever we had seen in the previous slide, and then yp is present here. So the yp what I am getting here is in terms of t, right? And the question was given me in terms of x. So I have to substitute back in terms of x. Correct? No, what we had said there, that e raised to t is my x, correct? So what I'm going to write down here, this is e raised to 2t, that means this is nothing but 3x square by 13, correct? This is nothing but 3x square by 13, and here my t will be what? T is nothing but log of x. So this is your minus log x and then cos 3 log x by 6. So the same thing you can find here, right? This is t is nothing but log x and cos 3, and then instead of t I am writing log x and then by 6. So this is complete answer with respect to your yc plus yp. Okay, now we are going to see the second question. So again we'll start with the very first step, that the given differential equation, what they had asked in the exam is suppose to solve this differential equation. So always we will start thinking of, can I use this ordinary differential equation solution using just finding CF plus PI? So if I want to find out CF plus PI, I need to have the given differential equation in terms of differential equation of higher order with constant coefficient. Fine. So coefficients are constant, that is okay, right? So you can find that coefficients are 1 and 1 only, but something more we can see here, right? So here I can see in my first term this variable is also present, x is also present. Here I don't find any x, that is okay. But because of the presence of this x, directly at this step only I cannot use CF plus PI, the straightforward method. So, but whether this method is in my Cauchy's differential equation, what we are discussing in this chapter, here it should be x cube. And if it is your d2y by dx square, so this term should get multiplied with x square, but these things are not present. So I cannot say that this is my Cauchy's homogeneous differential equation also. But we can rearrange this given differential equation. And how? If I am multiplying the left hand side and the right hand side with x square, so what will happen? So if I am multiplying with x square, so it will give me how much? X cube d3y by dx cube plus x square, because I am multiplying with x square. So x square d2y by dx square equals x, correct? Okay, now just concentrate on this function. So what is this differential equation? So we don't really bother about right hand side, whatever is given. In my left hand side, now I see that if it is x cube, it is d cube y by dx cube. If it is x square, it is d2y by dx square. So this is my Cauchy's homogeneous linear differential equation. This is linear because I can't find 2, 3 or any power here right now. But I'm not worrying about the power of x, because the x is not the dependent variable. Okay. Now, if I understood that this is my Cauchy's homogeneous differential equation, so two steps we have seen that additional we have to make. What was the first step? What was the first step? So we are going to write log x equals t. Okay. Or you can say that this is nothing but e to the power t is x. Anything is okay, correct? T is log x or e to the power t is my x. So this is my step 1. Okay. Now what is my step 2? in my step 2, I am going to rewrite these terms with respect to differential operator. But how long I will go? That means what I am saying, if I have x dy by dx, I am going to write it as dy. If only x power 1, so dy. I'm going to substitute x square d2y by dx square with, here it will be twice d written, okay, but here the d will be d, second time d will be d minus 1. If it is my x cube d cube y by dx cube, so it will be how much? 3 times I'll write that d, okay. Okay, now this will be my d minus 1, d minus 2. They all are multiplying with each other. Okay, so now further I will not go, because I can find that in my differential equation I have the term till x cube only. Okay, so step 2 is also done. Now if I'm going to rewrite this complete left hand side and right hand side in terms of d and t, so what will be the given step? So x cube d cube y by dx cube will give you how much? You can see here, right? So what I am writing down here? This is my d minus 1, d minus 2. This complete term I am writing down, and this y is actually common here, right? Now, plus this is what? Plus x square d2y by dx square. So x square d2y by dx square is nothing but d minus 1, right? And then y is present here. My right hand side is x, so x also I have to write in terms of t, because if I have written down in terms of d, that means I have changed the domain from x to t, because this d is what? This d is nothing but d by dt. So x also you have to convert with respect to your t. So x is nothing but e raised to t. So first term is done, right? So after that, what I have to think of? Now just concentrate on this given differential equation. Now this differential equation, if I will see, so I'll start finding my CF plus PI to solve this differential equation, right? So this is what given to me. So if I want to find out CF, because so how to find CF of this differential equation? So the very first step which we had seen in lecture number 2 and lecture number 3 was convert them into the d operator term. So it is already done, right? So the given differential equation in terms of d operator. Second step in finding CF is what? Writing down the auxiliary equation. In auxiliary equation, we don't worry about right hand side. We keep right hand side as 0, because to make it homogeneous equation. And instead of d, I'm writing down m, okay? And then we are not using this y present here. So why I'm doing it? Because I want to know the root of this auxiliary equation. How many roots you will find here? Since you see that the maximum power of m is 3 or maximum power of d is 3, so you will get 3 roots. That means you will be having 3 values of m that we have got here. So what we are writing down here? M minus 1 taking common, m minus 2 plus 1, because this has taken common, so only 1 is present, so plus 1. So this is nothing but this is m minus 1 only. So this term actually gives you m equals 0 or m equals 1 or m equals 1. Correct? No. So this we had seen in our CF, right? That we have the repeated real root. If we have the repeated real root, so the term will be C2 plus C3t e raised to t. And for this 0, this is C1 only. Correct? No. So this complete thing actually we had seen. So why I'm taking only 2 terms? Because only twice the root is repeated. Suppose one more one was there. So here it was C2 plus C3t plus C4t square. Correct? So finally we got what is my YC. Now I have to know that what is my YP. What is YP? We know that YP is nothing but right hand side function divided by whatever is present in my differential operator, this left hand side. So what is my phi x? The right hand side? Right hand side is just my e to the power t. So e to the power t divided by this complete term will be what? This is nothing but my YP. Okay, so what we were talking about? So the numerator is just the right hand side function, and the denominator is everything which is in terms of my d operator. Okay, now, so this is my YP. I will start solving this YP always by starting with type 1. If it is my type 1, type 2, type 3, type 4 or type 5. So this is straightforward type 1. Why? Because I can see the exponential term present here. What is my a? A is 1. So if a is 1, so my rule says in type 1 is you substitute that d with 1, that is d with a, and a is 1. So I'm going to write 1 instead of d. So 1 cube minus 2 plus 1, correct? No. So here again you are finding that the denominator is 0. Okay. So when my denominator is 0, so what step I have to follow? Go back to the previous step, right? No, this is my previous step, and just check the denominator. Numerator will be as it is. Check the denominator. So denominator, whatever is there, you just have to find out the derivative of this denominator. So derivative of this denominator will give you how much? 3d square minus 4d plus 1, correct? And whenever we find the derivative, right, I have to multiply this independent variable, that is t here, in the numerator, correct? And if it was your x, then you had multiplied with x, correct? Now what I'm going to do here? Now again, this is, I have to again check, right? I have to again check that this is what type and how my denominator is becoming 0 or not 0. So again, if we see that this is my denominator is 0. Why my denominator is 0? Because since this type is my type 1 only, because exponential term is present and a is my 1, so if I'm putting a is 1, d as 1 here, so it will give me what? 3 minus 4 plus 1. Again, this is my 4 minus 4, which is 0. So what I'll do? Again, I will find out the derivative. So finding out this derivative will give me how much? Numerator will be as it is. Numerator is here as it is. Finding out finding out derivative will be 3 into 2d, correct? Minus 4, and then constant will give you 0. So this is 6d minus 4. But we have to always remember that if I'm finding out derivative, I have to multiply one time the t or x, whatever is there, the variable there. So it is nothing but t square e to the power t by 6d minus 4. Okay, now again you have to check. Again follow the same method. Yes, this is my type 1. So what I'll do? I'll substitute d with 1, correct? So if d is 1, this is 6 minus 4, this is 2. So it is nothing but t square e to the power t by 2. Okay, so what next I have to do here? Nothing. Why? Because I don't find any d present here, not in the denominator or numerator. So that means I got my pi. So my pi is t square e to the power t by 2. But don't forget to convert it back into x, correct? Why? Because my question was asked in domain x. So I have to write it as my t is nothing but log x. So this is your log x whole square. T square is nothing but log x whole square. And then e to the power t was what? Your x. And then divided by 2. This term is this one. And what is this term? This term is the your yc. Again, yc is also in terms of x. Fine. Now, this is the third question. Again, the same method we will be following. That in this differential equation, we see that the variable is also multiplying with this derivatives multiplying, or it is in the denominator. So we cannot directly use my CF plus PI form because this is not in that standard form. The standard form is what? That ordinary differential equation with constant coefficient, but here my coefficient is variable also. So we will try to think that whether this is my Cauchy's homogeneous differential equation. So even that also we cannot find, because if it is d2y by dx square, it should be your x square. If it is 2y, so that means derivative is not there, so x should not be present here. And we don't worry about my right hand side. Right hand side should be just any function with respect to your x only. But can we make into Cauchy's homogeneous differential equation? That also we have to think, right? Because if we will not find any standard form, then what next we will be doing, right? So here what I'm going to do, can I just multiply the left hand side and right hand side with x? Why with x only? Because this, if I'm multiplying it with x, it will be my x square. That only I have to multiply. So it will give me x square d2y by dx square. and then x will get cancelled, right? So it will be free of x because it is free of derivative, and the denominator and the right hand side will be whatever, I don't worry, but it will be your square plus 1 by x, right? No. Okay, so what we now going to do, so this is what we have got here, right? No, so this is only what we have got, and this form is my Cauchy's homogeneous linear differential equation. So I have to actually use two additional steps to go to check that CF plus PI form. So what is my first step? So step 1 is what I have to always do the same substitution. That means t equals log x, or I will say that e to the power t is my x. Always I have to follow this step number 1. Okay. So if I'm writing down in this fashion, so what is my step number 2? So step number 2 is the same. If I have x dy by dx, only x power 1, so it will be dy, and this way I'll just keep on writing down. But how long I will go? Since the power of x in left hand side is 2, so I will just find till x2 y double dash only. Correct? Fine. So now this step 2 is also done. Now what I have to do? I am going to rewrite the given differential equation in the operator, the differential operator term. So this is my left hand side, correct? No, this is my left hand side. Okay. And in right hand side also, don't forget that if you have come into D, that means you have come into T domain. D is nothing but d by dt. So in the right hand side also, you have to write x as t. Whatever x is your e raised to t, so same form you have to write down. Okay, so now this is valid term to find the CF plus PI, correct? So what I'm going to do here, I'm going to just rearranging this term, this left hand side, and starting the step with finding out CF. So CF is the first step for CF, that means writing down the things into D operator, done. Second step is finding out auxiliary equation, and the third step is also done for CF. That means based on the nature of root, I just written down what is my YC. Since the roots are real and different, so the YC is this much only. This 2 is present here, e raised to 2t. This minus 1 is present here, e raised to minus t. And this C1, C2, two constant coefficients are there. What will be my YP? So YP is just the right hand side, whatever is present. This is my right hand side divided by whatever is my left hand side. That means e raised to 2t plus e raised to minus t divided by d square minus d minus 2. This one I am seeing. Okay. So this is your YP. Fine. So same thing. These two terms are there. You can just write it as e raised to 2t by this much plus e raised to minus t by this much. Correct? Okay, so we are done with these two terms. Again, the same method we are following, since we got that the denominator is 0. So we are multiplying with t and finding out derivative of one previous step, and then keep on following the same method, and we are done with my P1. Similarly, we are done with my P2. Okay, and then finally we got my YP. Don't forget to convert this t into x, and then finally your complete solution is yc plus yp. So you have written down your complementary function also with terms of x only. So finally this is your answer. So if you find this class useful, please like and subscribe my channel. Thank you.